Last episode ended with a bill. The video list needs 2 services, so when one is down, it is down. Today we add authentication, something every request needs and it costs nothing. No lookup, no shared store, and it keeps working when the service that issued it is switched off. Someone logs in against identity service. Now the monolith has to know who they are. The normal answer is a session. The server remembers you and hands back an ID it looks up on every request. That works beautifully right up until you have 2 services, because the store has to be reachable by both. Put it in one service's database, and you have rebuilt the shared database we spent last episode removing. Put it in Redis, and you have added a network call to every single request in the system, and a new thing that must never go down, because when it does, nobody is logged in anywhere. So here is the pattern. Give the caller a signed statement of who they are and let every service check that signature itself. The claims travel inside the token, subject, permissions, expiry, and the signature is what makes them trustworthy. Nothing gets looked up because there is nothing to look up. The session did not move somewhere else. It stopped existing. 6 things decide whether this works. The claims are the session. Everything a verifier needs travels with the request. Signed is not encrypted. Anyone holding the token can read every claim, and we will prove that in a minute. Minting and verifying must be different capabilities, which means asymmetric keys. The public key gets published as standard address, so adding a service is configuration, not code. You verify more than the signature, expiry, and who issued it. And you keep the lifetime short, because expiry is the only way a token ever stops working. And this is how the internet actually logs in. When you sign in with Google, what your application receives is a signed token it validates against Google's published keys, without ever calling Google. Auth 0 and Okta are built entirely around this shape. Every pod in a Kubernetes cluster authenticates with one. And GitHub is the honest counterexample. Their access tokens are opaque, checked against GitHub's own store on every call, which costs them a lookup and buys the thing tokens cannot do, revoking a leaked credential the second it is reported. Let's look at the code. Here is the user's table, and the interesting thing about it is what is missing. There is no session column, no token column, no logged in at, nothing that grows when somebody signs in. If this table had a session sibling, every service would need to read it. And that is the shared database episode 6 spent its whole runtime removing. This is the heart of it. Identity service holds a private key, and it is the only thing in the platform that can create a token. Everyone else gets the public half and can only check one. The alternative is a single shared secret, and that sounds convenient right up until an incident, when you ask who issued this token, and the answer is any of the 11 services that had the key. With a shared secret, there is no such thing as a service that can only verify. And here is the entire integration on the other side. Not a library we wrote, not a client, not a call, one line of configuration pointing at the other service's public keys. The monolith fetches that key set once, caches it, and from then on every token is checked with arithmetic in this process. That cache is going to matter enormously in about 4 minutes. Let's run it. Identity service on 8081, which issues tokens, and the monolith on 8080, which verifies them and has never been told anything about how they are made. Now log in as one of the seeded creators. Email and password over to identity service, and back comes an access token. That bcrypt check is the one deliberately expensive moment in this whole design, and it happens once, no matter how many requests follow it. And here is the thing people get wrong about these. That token is not encrypted. The middle section is base 64, and anyone holding it can read every claim inside: who you are, which channel you own when it expires. The signature stops somebody changing it. It does not stop them reading it. So never, ever put a secret in one. Now use it. Publishing a video needs a token, and notice what is not in the body I am sending: the channel. That comes out of the token, so I cannot publish to somebody else's channel by editing a field. With the token, 201 created. Without it, 401, and the monolith did not ask anyone's permission to say that. But hold on. I can read the token, so why can I not simply edit it? Let's try take the real token and change one single character of the payload. 1. Everything else is identical. 401. The signature covers the header and the payload together, so any edit at all breaks the arithmetic, and reproducing it needs a private key that never leaves the other service. So it cannot be forged and it cannot be edited. Which raises the obvious question: how does one of these ever stop working? Only one way. It carries its own expiry date and nothing else can end it. Nothing looked this token up, so nothing can take it away. The only thing that ever stops it working is its own expiry date sitting inside it. Here is a token deliberately issued to live 5 seconds. Publish immediately, fine. Wait a few seconds. Publish again, 401. And the monolith tells us exactly when it expired. That check needed no network and no database. The deadline was inside the token all along. It also means that for those 15 minutes, a stolen token is simply a valid token. One last thing, and it is the subtlest idea in the episode. Verifying a token is arithmetic, but deciding what is allowed to go into one is a judgment, and it can only be made in one place. Watch what happens if I register a brand new account and try to claim a channel that already has an owner. 409. Refused. If identity service signed that, the monolith would honor it correctly because the signature would be perfect. The lie would be ours. A claim has to be earned before it is signed, because afterwards everyone believes it. And now the part I have been building to all episode. I am going to stop identity service completely. The same shutdown that turned the video list into a 503 last week. It is gone. Now publish with the token I already have. 201, it worked. The monolith never needed identity service because everything it had to know arrived inside the request, and in the same breath ask for the video list. 503. Same outage, same second, 2 endpoints, opposite answers. And the only difference between them is whether the data traveled with the caller or had to be fetched. So the honest trade. We bought authentication that costs nothing per request, needs no shared state, and survives the issuer being down. We paid for it with revocation and not just for tokens. Restart identity service with a new key and the old tokens keep working because the monolith cached the public key and has no way to learn it was thrown away. That is the same limitation twice. Everything about this design buys availability by giving up the ability to take something back quickly. The signer, the key endpoint, the 3 lines that verify, and the decision record for why it is not a shared secret are all on the branch. Next episode, we go after this design's one real weakness, a stolen token that stays valid, and what it costs to be able to take it back.